My name is David Eisenbaum. I am the project manager for the group. And on the Scrum, we have Nazeni. Our QA is Savak. We have two developers, Joanna and Sheaf. Here's our team picture. This was after an all-nighter. So our data-driven statement is this. According to the US Census, 93% of households with school-age children had to do some sort of distance learning. So nucleAR aspires to bridge the gap between nuclear science, interactive learning, and the accessibility of having the experience in your own home. So our curriculum is built off the Navigating Nuclear website, which they call a virtual field trip, which is kind of an oxymoron because you're not taking a trip. They have a chapters for videos that are really boring and have very limited interactivity. So we try to use augmented reality to try to bring that interactivity that a real field trip would give. That's the website. I'm not going to visit it. So here's our product description again. nucleAR is a AR iOS application that will enhance the website I just showed, using a virtual escape room with a series of puzzles that the answers are in the videos. So there are three applications for virtual escape rooms. Escape the Room AR is 127 megabytes, Scriptum is 300 megabytes, and Aria's is 500 megabytes. Ours is 16 megabytes, so we were able to compress our objects and files pretty well. And the number of real escape rooms, which have been a common trend, especially in Los Angeles, has grown massively. It's a fun activity with your friends. So the technologies we used was Swift UI to build our user interface, along with storyboards. We actually used both. ARKit, which is Apple's first library to build augmented reality applications, which was released in 2017, and Reality Composer, which was released in late 2019 to build even more scenes in AR, including audio and a more game-like experience. So documentation was really limited. First, they're Apple, so they don't provide any code examples. And since they're new, there's not many online resources. We actually talked about maybe making a tutorial for other people. To build our objects, we first built them in Tinkercad, and then we used Blender to transform the object into a .usdz file. And to paint that file, we used Substance Painter. For our database, we used Cloud Firestore and Firebase offered by Google. Google, in comparison with Apple, has great documentation and code examples for everything. And a couple of us already had experience with authentication with Firebase. So it was a no-brainer choice for us. The curriculum, Navigating Nuclear, offers a PDF which describes the objectives of what the students should learn in the virtual field trip. And we tried to align our puzzles with that educator guide. So our key mechanic are the puzzles. You can see the flow of our app in the bottom left. So these will be presented with a home page and then a start screen or start button to start each of our 4 puzzles. And they can either complete those puzzles or they run out of time and the nuclear facility explodes. So this is our first puzzle. It's very similar to Paper Toss, a very popular iOS app, which was very early, where you had to toss a ball into a trash can. That model is very ugly. So pretend that that cylinder is a nuclear reactor and the ball is supposed to be argon, which stabilizes elements. The second puzzle is they're presented with a nuclear reactor table where they're prompted to insert certain elements and turn on certain switches to either cool or not cool the reactor, which are explained in the video. So here's our demo. Now there's 3 screens here. So the first, let's just look at the first one. The first one is just a link to the website. And starting with the second one, I wonder if I can restart this. Okay, so they're presented with 2 elements, argon and oxygen, and they have to select the right one argon stabilizes, and oxygen explodes because it's very unstable. And then once you select the argon, you have to shoot it into the reactor. And this person is really bad at it. Finally got it. And once you get it, you get a correct prompt. The second one is a lot more complicated. And so they have the nuclear reactor table in front of them with certain elements. And they are prompted with pressing that button. It should show a prompt soon. Yeah, it's really small. It's really minuscule, but you can step up in your life to see it better. And so they have to drag that element into the reactor core. And then if they need any help, they can press that nuclear symbol right there. That is detailed in the instructions page on the home screen. Yeah, and then tap on the radioactive element that belongs in the ATR, which is a test reactor. And then they get that message that the nuclear meltdown has been averted. And then they get a congrats screen after. So some of the data we collect are username, email, passwords, first name, last name, date of birth, and gender. And mainly we want to collect date of birth to see if a certain age group performs better on the puzzles. And also if a specific gender is better at a puzzle. We also want to see which puzzle is the hardest and the number of attempts to see if they're learning the puzzle. And also time. They want to see if they're getting better or worse as time progresses. So we have the raw data on the left, and we have the user's number of attempts at the top here, and then the timestamps for each puzzle. And then we have the average timestamp across all attempts, the average for the class, the standard deviation for the class, and as well as the user. And we also have global averages among the everyone who does the puzzle to compare. So here's another data storage diagram that shows the amount of bytes that each profile will collect, as well as the amount of times, which is 24, not going to do mental math, 48 plus 60 total, and collecting each user. And here are some graphs that the teacher, these are what the client can see on request. So they can see a certain student's average compared with the class average and the global average. And here are the amount of time she spent on each puzzle and the number of attempts. This is the user view of the data they can see. They can see a visual representation of the correlation of attempts and duration of the escape room. They can see their best overall time to finish all the puzzles. They can also show their best stage and their total number of attempts. This is the client view where they can see all the times for girls in a scatter plot and time for boys. And as well, this scatter plot is crazy, which is the number of the x-axis. I'm sorry, the y-axis is which puzzle, and the y is the number of milliseconds it took them to complete it. So yeah, the client can request these graphs, or they can just get an Excel file with all the raw data. And so in conclusion, we want to implement more puzzles because there's so much material in the virtual field trip, but we only had less than a year to complete this. Hopefully we can put this on the App Store with Navigating Nuclear's permission. So we had a lot of fun on this project with working with new technology, and thank you for listening.
Alrighty, any questions for our speakers?
I'm sorry, I think you covered this, but I forgot already. But
yeah.
So for the class data and all that, you're sending data to a backend. That's the Google server, is that right?
Yes, yes. Firestar
okay.
collects
right, okay, yeah, it's coming back. Sorry.
yeah, that's all good.
I'll throw a question of my own in there. So with the use of like a NoSQL backend, how did that impact development? Because I know that I don't really have any experience with using NoSQL stuff, but I have a lot of experience with SQL based stuff. Just kind of like, did that require you to like really think differently about how the app was structured, or kind of what are your thoughts there?
We were only storing about like 8 things, so it wasn't really complicated at all that impacted development, and especially with their documentation, it helped a lot. We kind of avoided the learning curve and pre-processed all the data ahead of time as well.
Okay.
Now, your app was a lot smaller than the other ones you looked at. Is that because you only had a few games? What's the difference between what you have and they have?
Yeah, the average time of ours is a lot shorter, but of course ours is very modular and we can add as many puzzles as we want. And of course, the number of megabytes our app will increase by will increase as the number of puzzles increases. But we were before we used the AR kit, we used Unity, and with only one puzzle, our app was around 200 megabytes, and so we switched to Xcode and Apple, and we were able to reduce the size drastically with a different type of file.
I think you might have mentioned this in the talk already, but why the particular set of puzzles that you picked for that? Like what was like? I'm assuming there's some sort of prioritization that was done there.
The puzzles are in order with the virtual field trip. We have a layout of more puzzles. We had a lot of ideas for puzzles, but we kind of just each picked which ones we liked the most and prioritized those. Like I thought the basketball one was really fun, so I decided to pick that one, or the shooting one.
I'll ask this. I asked this question of another group, but I like this question in general, so I'll ask it to you too. So if you could, let's say, taking all the knowledge you have now, and you had to do everything else, everything you did again, knowing what you know now, is there anything that you would do differently in development?
Yeah, we would probably cut out. I don't know if anyone has iOS experience, but we probably cut out storyboards because that was the most buggy thing we've had to deal with. They're very well known to be unstable, and that's why Apple is moving away from it and using Swift UI. So we implemented Swift UI later in the project, but I would have just straight up used Swift UI only. The transitions are a lot cleaner and more options and to build your UI with.
Okay. Are there any more questions for our speakers? And audience, you're free to ask something too in the chat if you want to. Question for the chat: why AR instead of VR?
Why AR instead of VR? We believe that since it's a virtual field trip, the number of people who have VR headsets is much less than the people who have iPhones, especially since the Navigating Nuclear website is only for US students since it's in English. So that's our reason. VR is, I think we looked at the data of the number of people who have VR, and it's less than 50% of the population.
Okay. Are there any more questions?
So for the AR part, so you're using whatever the camera's picking up in the background. Was there anything other than motion key to that? I mean, you weren't using any things in the environment, or?
There's automatic the floor detection in AR kit, and also if you're in a dark setting, it will have a lot of trouble. And if it detects the low setting, you'll get a little toast prompt saying that you need to get better lighting.
Okay.
So most of our bugs revolve around lighting.
All right. Are there any last questions? Okay.
Thank you.
With that, let's thank the nuclear group